Well, as you can see, this is titled Factoring. And there's as I said before, I'm assuming that you know how to factor. What I'm doing here is reminding you of some of these techniques, and then in a few cases maybe showing you something that you don't recall. And then at the end, we're going to look at some special kind of factoring that most likely you have never done before. So let's begin with factoring something that we should be fairly familiar with. Pardon me for fumbling with that. See if I've got an example that I want to do here. Suppose we're asked to factor. Okay, so here's example 1. We're asked to factor, and whenever we see factor, we know we're supposed to factor completely. Like if we're asked to factor 12, we wouldn't just say 2 times 6. We'd say 2 times 2 times 3, or 2 squared times 3. So we factor to prime factors as far as we can go. So in this case, we're asked to factor 7x cubed, minus 28x. And in this particular problem, this is the easiest type of factoring to do, because we first off notice there's an x factor, in each of the terms. So x is a common factor, and that's really what we're noticing here. And we also notice that 7 goes into the first term, 7, and it also goes into 28. So 7 is part of the common factor. So we recognize that we'll factor out a 7x, and we call that 7x the greatest common factor. And so then we write our parentheses and just think backwards and think 7x times what in this position gives 7x cubed, and of course we need an x squared in that position, don't we? And then of course we need a minus sign, and then we need a 4, because 7x times negative 4 gives negative 28x. And so this technique that we're using is called factoring out a common factor. And it's the simplest thing for us to do, and we always want to try it or at least consider it. And we'll do this a lot in this class, I think. Okay, example 2, and again, the directions are to factor, so I'm not going to write that each time. In this particular case, the expression we're going to factor is x squared plus 10x, sorry about that, plus 24. Now, this is a trinomial, and the technique I use when we're factoring a quadratic trinomial, meaning the highest power is 2. I recognize, and I bet you do too, that that's going to come from a binomial times a binomial. And then we compare and say, okay, well, we know the way we multiply these binomials, the first term times the first term has to create the x squared. And so the way that would happen is if we said x times x, that will create x squared. Now, what I teach is that the next thing we consider is that sign right there. That sign being positive tells us that when we multiply the last 2 parts, we have to get a positive result. And that can only happen is if we have a positive times a positive, or if we have a negative times a negative. Now, if we had a negative times a negative, that would create a positive, but we'd also have to have a negative someplace else because we'd have a bunch of negatives. And so what we end up doing is deciding that if the signs are the same, like we've decided here, and that's based on that being a positive last term, then if we look at this term, that will tell us whether they're both positive or both negative. And so we know they're the same, and that term that I just pointed out, being positive, tells us both terms are positive. And then we have to figure out the numbers that we can multiply to give 24 at the end, but at the same time give a 10x in the middle. And so this is really a guess and check. And I'm thinking if I say 6 times 4, that will give me 24, and that's also going to give me that middle term 10x. And what we're really claiming is that if we multiply all this out, we're going to get x squared plus 10x plus 24. And we do know that when we multiply it out, we'll get the x squared at the beginning and the 24 at the end. So our only really question is, do we really get a 10x in the middle? And where does the 10x come from? Or where's the middle term come from? Well, it comes from multiplying the x and the 4 on the ends, okay? And then in the middle, we'll have a 6 times, in the insides, we'll have a 6 times an x, which is a 6x, and we end up adding those together to get that middle term. And since those do add to give 10x, we know we have it factored right, don't we? So that's, again, no special new information. Now, what we also know, but factoring is a very important part of this course because we have to solve equations a lot. And a lot of times to solve equations, we need to be able to factor. Now, in the next example, I want to point out to us, let's see what I'm going to use. We're going to factor 15x squared minus 23x and minus 28. And if you've done enough factoring of this type, you say, oh, yuck, that's a 15x squared. Now, what we do know, and it's the big numbers that kind of bother us, what we do know is that when we factor this, it will be binomial times binomial. But now we have to worry about the first term giving 15x squared, and there could be several ways. We could actually say 15x times x, that'd give 15x squared. Or we could say 5x times 3x, that would give the 15x squared. And I guess 3x times 5x, but that's the same pair. And we don't really know which one it is. And so we just make a guess, and we'll test it. So let's try the 5x and the 3x. Okay, that's my first guess. Now, the next thing we do is we look at this sign. And that being negative tells us these signs have to be different. Now, if it's positive, the signs have to be the same. But if it's negative, we have to have a positive times a negative or a negative times a positive to create that. So it's either positive times negative or negative times positive. And so I don't know whether if the first one is a plus and the second one's a minus or vice versa. I'm just guessing. I wrote something down and we'll adjust as we need. Now we're worried about the numbers multiplying to give 28, and that's about as big a problem as anything because we could say 28 times 1, we could say 14 times 2, we could say, 7 times 4? Is there anything else that will work? I don't think so. So we don't know which one of those pairs is going to work. And in fact, none of them may work with 5x and 3x, but we just guess to get started. And so I'm guessing a 7 and a 4. And when I'm checking that out, I know that I'm going to get 15x squared, right? I know that. And I know I'm going to get negative 28 in the middle if I multiply that out. The problem is what happens, in the end. The problem is what happens in the middle. And you notice here that the middle will have a negative 20x, 5x times negative 4, and we'll have a positive 21x, 7 times 3x, and of course together that gives x. And so if we were to multiply that out, we get this, and we know that's not right. So we try again. Okay? Now, we don't necessarily need to change our numbers. We might just need to change where we put them. We might put the 4 in this place and the 7 in this place. Now, we might be able to check real quickly here and notice that, look, 5x times negative 7 is negative 35x. Oh, look, and 4 times 3x is positive 12x. And if we add those together, we get negative 23x, don't we? So that we know when we multiply these out, we'll get the right middle term, and we've already set it so that we get the two correct terms at the end. And so our conclusion is that this is the correct factorization. Well, let's continue with some other techniques I want you to be familiar with. So far, we factored out a common factor, and that's one technique. And then we factored trinomials, and that's a technique that we've used before, and we should have plenty of experience with this. This next technique is when we have the difference of two squares. And so let's look at an example of factoring here. So example next. The next example, we're to factor 9x squared minus 16. Now, this certainly isn't the same type of, this isn't a trinomial, and we see there's not a common factor, and so we have to come up with another technique. And what we recognize is when we have two terms and a minus sign in between, we wonder whether the technique we're going to use is called the difference of two squares. And if it's the difference of two squares, that means it can be written as something squared minus something squared. And if that's something we called A in the beginning and that's something we called B in the end, if it's an A squared minus a B squared, then we've learned that that can be factored as A plus B times A minus B. So if we think that this might be the difference of two squares, then what we try to do, like I said, is write it in this format. And maybe we have enough experience that we don't need to go to this trouble, but this is just the idea in general. So we ask, what can we square to give 9x squared? Of course, 3x will work, won't it? And what can we square to get 16? Of course, 4 will work. And so our A value is 3x and our B value is 4. In other words, this will factor as a product of a sum and difference. We have a plus in one of these binomials and a minus in the other, and it's more or less by formula. The 3x goes in both first positions, and the 4 goes in both second positions. And we should have enough experience that we recognize when we multiply that out, we will in fact get 9x squared minus 16. Now, here I want to give an additional example to just make this clear, that if we had something like x squared plus 4, the common mistake for students to make is to say that this is x plus 2 times x minus 2. And then they check that out, and that doesn't work. And so they're going to say, oh, well, that's x plus 2 times x plus 2. Well, of course, x plus 2 times x minus 2 actually gives x squared minus 4, doesn't it? And x plus 2 times x plus 2, remember, we'd have to use FOIL. And if we FOIL that out, we'll get x squared plus 4x plus 4. That's not x squared plus 4, is it? So that doesn't work. And there's not much more opportunity. I mean, we might say, oh, well, what about x minus 2 times x minus 2? But if we multiply that out, we'd FOIL again, and that's x squared minus 4x plus 4. That's certainly not just x squared plus 4. So that doesn't work. And we probably learned in the past, we've said that this particular polynomial is prime. Now, in college algebra, we learned that every polynomial of degree 2 or higher can be factored. But sometimes we have to introduce irrational numbers or even complex numbers to be able to factor it. So this isn't really prime, but it's prime if we try to only use for using rational numbers. That is, whole numbers or fractions. To factor this particular example, we would have to use complex numbers. And so as far as we're concerned, the normal factoring technique will not work. Okay. Now, this next example is one that we do. This one may be one that you're not familiar with, or it's been long enough that you've forgotten how. So in this case, we're going to ask to factor x cubed plus 8. Now this looks strange, but this is what we have to recognize here. To factor this, we have to recognize that it's the sum of two cubes. See, that in the first position, we can cube x to get x cubed. In the second position, we can cube 2 to get 8. So we have the sum, the addition of two things being cubed. Now, the sum of two cubes, so we'll write it this way, a cubed plus b cubed, can be factored. It's kind of a strange factorization. It's a binomial times a trinomial. And the binomial is a plus b. That's what we're cubing in the first term, for the first term, and what we're cubing for the second term. And the second factor is a trinomial. And the second factor, it's the a that we have in the binomial squared, and then the sign that goes right here is opposite that plus sign, okay? And what we put in this position is the a times the b that we have here and the b that we have here. And then this sign in the trinomial is positive always, and what we have in this position is b squared, the b that we have in that binomial squared. So if we look at this example, our a is x and our b is 2. So we have x plus 2, and then our trinomial. So we look at this x, that's our a, we square it, that's what goes there. Then a minus sign goes here. Now, the term that goes in the middle, see, that was a squared. What goes right here is a times b. And a is x and b is 2. So that's 2 times x. Okay? And then this sign's positive, and what goes right here is b squared. And remember, b is 2, so we have a 2 squared or a 4 right there. And that's the factorization. You might need to convince yourself that if we multiply that out, we get x cubed plus 8. Now, I would also say here that if you look at that second factor, x squared minus 2x plus 4, that's a trinomial, and a lot of times we'll try to factor those. But in this case, we call that an irreducible quadratic. An irreducible quadratic, that means, kind of like above, it means this is prime unless we use irrational numbers or complex numbers to factor with. So under normal circumstances, we would call it prime. That's really the issue. We know it can be factored, but we have to use strange numbers to factor it. Okay, let's now go to the next page and let's do another factorization that has to do with this method of dealing with cubes. And let's see here, rattling my pages for you here, get things settled. I apologize for the delay here. Usually I would just pause this so I can get things straightened out. I know it's making a lot of crackling there. Okay, I've gotten settled now, and you can see that we're continuing factoring, and in this case, we're asked to factor 8x cubed minus 27. Now, the form that we're going to use here is similar to the last one. This form of technique we're going to use is called the difference of cubes instead of the sum of cubes. Difference of two cubes. And so the difference of two cubes depends on the fact that we have something cubed minus something cubed. And the factorization technique looks similar to what we had when we had a cubed plus b cubed. Okay, so we look at what we're cubing as our first term. So we have a binomial where the first term is a. That's what we're cubing to get the first term. And then the minus sign, which matches, of course, the minus sign in between. And, of course, what we're cubing in the second term to get b cubed. So that's just the b. Now that we have a trinomial next as one of the factors, and as before, the first term is a squared. Now we look at this a and we square it to get that term. Now the sign that we have here next is plus. Notice before, when the sign of the binomial was plus, the first sign in the trinomial was minus. Here, when we have the sign of the binomial as minus, that first term sign in the trinomial, excuse me, the first operation in the trinomial is a plus. And so that we say this sign is opposite the sign that we have there, and that will work in both cases. And then we look at the two terms, that we're taking an A and subtracting a B, but we all know the product, so what we have in here is just A times B. We ignore that minus sign in the binomial and just pick out the B part, the positive part there, so it's A times B. And then as the case before, I said that this sign is always positive, and what I meant is also positive when we're talking about the difference of two cubes. And what goes here is B squared. So for us to factor above, we need to be able to say that it is the difference of two cubes, which means we'd have to be able to write it in this fashion. And we recognize if we cube 2x, we get 8x cubed, and if we cube 3, we get 27. So our A is 2x. See, that's what we're cubing in the first place. And our B is 3. And so when we go about factoring this, we would have binomial times trinomial. And in the binomial, we have the A, 2x, minus the B, 3. And then in this first position, remember, we have A squared. But A is 2x, so we have to square 2x, and that gives us 4x squared. And then we remember that that sign is positive. And remember, in this second position, we have an A times a B. But A is 2x, and B is 3. And so we have a 6x there. And then we recognize this sign is also positive. And what we have in the next position, of course, is B squared. And since B is 3, then B squared is 9. And so this, again, is a factorization. And once more, that trinomial, we would consider an irreducible quadratic, or we would consider it prime. So we have, in fact, factored 8x cubed minus 27. Okay, so far we've looked at the standard forms of factoring. What I really want to do next is some unusual forms of factoring, and they're really just a variation of what we already know how to do, but we're going to have to extend what we know how to do, because we'll deal with some stranger forms of factoring a little later in the course. We'll have to be able to deal with this. So I'm going to call it factoring special forms, but I'm going to do that in a separate session altogether. So I think I'll pause or stop this session, and we'll start up with another group of factoring techniques.